Perfect. Okay. And now let me just double check it's recording. Okay. Yep. Recording has started. Good. Also use my own software. Excellent. So that should be recording as well. Excellent. Right. Without further ado, let me load up my presentation. Okay, perfect. That's fine. Now, fingers crossed, I hope if I start the show, hopefully you should be able to see my screen. I will just leave it open for a quick minute because my computer decided to do some sort of security setting in order to allow me to share it. But fingers crossed, you guys should be able to see it. But if you could just confirm very quickly in the chat, avoid me having to go through 40 minutes of nobody actually being able to see anything and just my face. Okay, double check. Perfect. Okay, we can see. Excellent. Good. Oh, you shut this. Good. That is good to know. Maybe it just stopped. Let me try it again. Sorry. Thank you for that. Unfortunately, you can't have both open at the same time. Let's do that again. Share window presentation. Excellent. Right. Cool. Now that we know it works, I am happy to continue. I'll tell you what, ThinICE, if anything crazy happens or goes wrong, just if you shoot me a text, that'll be the most direct way. I can't have both open on my same screen, unfortunately. Okay, so perfect. Without further ado, I will welcome all of you. Good morning, good afternoon, wherever you may be in the world. Thank you very much for joining us today. My name is Sami Yura. I represent a company called Phase Change Material Products Ltd. We are a UK-based manufacturer of phase change materials, and we are heavily focused on manufacturing and research and development. And the purpose for this webinar today really is to share the knowledge and share the work that we are proud to be a part of the Surefit, basically encompassing the EU Horizon 2020 scheme, which if you're not familiar with what that is, essentially the Horizon was a scheme between 2014 and 2020 the European Union Commission set up in order to basically push forward innovation across Europe and to develop new technologies, ideas, and concepts. And Surefit was one of the successful projects that was funded in order to push forward building technologies to make the world and make Europe more environmentally friendly. So that'll be the purpose of my presentation today, is just to very quickly give you a breakdown as to what the project entailed, what it was aiming to do, and what the key technologies were within the project. So here is just a quick brief overview of how that will be done. So essentially, like I said, I'll give you an overview of the project, of what exactly it was aiming and is aiming to do, what the key technologies are that make up the project, and then explain a little bit about the demonstration phase, which is whereby we actually go and install these technologies that we've been developing and working with in real world buildings to showcase the actual performance and efficiencies. Then also quickly, briefly mention who the stakeholders will be, who are we targeting with these technologies, who will be the end users, and then what we hope the expected outcomes and benefits of the technology will be for both Europe, but then also the greater world. And then at the end, there will be a 20-minute, up to 20-minute session for any questions and answers that any of you may have. So very quickly, I've given you a brief overview of what the Horizon project, or scheme was. And so I just want to really quickly give you a breakdown of what the Surefit project is, and what it's aiming to do. So in its most basic kind of explanational form, it's essentially trying to really fast track the renovation of existing buildings, so the existing stock of buildings we have across Europe, and make them basically more innovative, cost effective, and to utilize more sustainable technologies in order to lower their carbon footprint. As we know, the world is going through an unfortunate shifting, is going through a stage of climate change. So we are trying to push forward technologies that can simply help make the existing housing stock, which is one of the biggest polluters and one of the biggest impacts, make them more efficient and environmentally friendly. The key for this project is really to find technologies and develop technologies that are simple to integrate into existing buildings. Because although we can do great things with new buildings being built over the next decade, 2 decades, and further into the future, we have an awful lot, and most of the buildings in the world are already existing for obvious reasons. So we need to find a simple way to be able to integrate those technologies that aren't a massive burden to the building owner, nor a massive expense. And through doing this, we're targeting near zero energy by reducing heat losses in the building envelope, as well as reducing energy consumption. So those are two of the key points that I want to stress, is that by making a building more efficient, we can do that by reducing the amount of heat they lose, so we don't have to use as much heating in the winter and the colder months, as well as, most importantly, reducing energy consumption, which obviously makes everything more efficient and means we need to burn less fossil fuels and ideally shift more towards greener, sustainable sources of energy. So again, just re-emphasizing those heat loss objectives, you can see here a very simple thermal image chart, or thermal image shot, that essentially shows on the right side a house that has very, very poor insulation, and then a house on the left that has very, very good insulation. And you can see in red clearly the amount of heat that is escaping through that building envelope and through those glass panes. And so essentially, by simply improving and retrofitting into a house better insulation, you can trap a lot more heat inside, which also means you have to use less energy. So that, again, really feeds back into the project's goal of decreasing energy consumption for heating, cooling, ventilation, as well as lighting. And that this will hopefully increase the share of renewable energy that we can use in buildings. These are the partners that are involved in the project, and we have an extensive list here that spans the whole of Europe and the United Kingdom, and basically spans across different industries and different expert areas, which is really beneficial for the project because we're able to share knowledge and experience and develop these technologies in ways which wouldn't be possible without having such a great relationship and having such a great span of partners. And so we are, like I said, all over Europe: Portugal, Greece, the UK, Turkey, and France, Finland as well as Portugal, just to name a few. And here are the logos and partner names for you to have a quick brief view over. So the key stakeholders for these technologies, people who will be benefiting from these, it's fairly simple to break these down. Essentially, we are looking primarily at building owners and users. These will be people, these will be businesses, people who own different premises, whether they be residential, commercial, or industrial. We will also be targeting manufacturers, so people who are already in the industry with which our technologies lean into. We need to work with them, as we are trying to, in a lot of cases, break the norm, the normal way of doing business or the normal way of designing buildings. We need to work with them in order to be able to push these new ideas forward. And then product and service developers generally leans into the people who will actually be selling and installing these technologies. This is a big focus that we found throughout the project, is it's no good having a technology or a product if you have nobody who can physically install or work with these technologies. So that's one of the key areas we are working and hoping to develop and build relationships in the future, is to just allow for the easy retrofit, which is one of the main goals of these technologies within the existing housing stock across Europe and the greater world. So now I'll get quickly into the brief summary of what technologies encompass the Surefit project. And in very simple terms, we've got the 5 key technologies here on the left, and then on the right are visual representations or images of these technologies. So leading off, we will be talking about PCM passive cooling panels, which is our main input into the project and the main technology and know-how that we bring to the table. But I'll also be talking about solar hybrid PV thermal collectors and how those work. PV vacuum glazing, which is an incredible concept and technology. Retro solar blinds, and also Silica aerogel panels. And so I'll be briefly covering numbers 2 through 5 and giving a bit more of a thorough explanation of our own technology, as obviously it's the one I'm the most familiar and comfortable with. So PCM passive cooling is a concept whereby you can cool a space, a building, or a room without the need for mechanical or electrical heating or cooling elements. So essentially, we can take away the need for mechanical cooling, so conventional heating, ventilation, air conditioning equipment, and we can do it by using nature. And so my hope over the next few slides is to explain how exactly is that magic possible. So very quickly, who we are as a company. I did say we are Phase Change Material Products Ltd earlier, but we are a UK-based chemical research manufacturing company. We're specialized in phase change materials. And over the last 20 years, we've been involved in multiple forms and programs of research development, both internally and externally. And we consider ourselves, over those 2 decades of experience, to be global leaders in PCM technologies and PCM know-how. And it's just a key point here is we've been involved in roughly just over £8 million worth of R&D funding over those last decade or two. So very quickly, what are phase change materials? It's a very good question and one we always have fun trying to explain. And the best way I've found is to really simplify it to its kind of pure essence. And basically, all PCMs are different chemical solutions. But what those chemical solutions are capable of doing is storing and releasing thermal energy during the process of melting and freezing. And it's during this process that the phase change materials are able to release large amounts, they can both store, and release large amounts of energy in the form of either heating or cooling. Depending on what PCM solution we put together and we mix and we use, we can apply it to both heating and cooling. And I always like to use this very simple analogy that phase change materials, or essentially our thermal energy storage systems or solutions, in simple terms, they can be seen to represent a thermal battery. The same way as in your phone or in your laptop or in your car, you have an electrical battery, which allows you to store electrical energy in the battery to then use at a later time when you need it, whether to make a phone call or to watch a video on your laptop or write an email. PCMs and thermal are basically thermal batteries, allowing you to store thermal heat or cool energy in a form of battery to then use at a later time. And that in its purest and simplest essence is what phase change materials are. So the Surefit technology offering for PCMs, as I briefly mentioned, is for passive cooling. And the idea behind passive cooling is a fascinating one to me personally, but it's the idea that we can store the cooler nighttime energy. So in most areas of the world, nighttime temperatures and ambient conditions are lower than daytime ambient conditions. So with PCM acting as our thermal battery, if we can encapsulate that in a plastic housing or a plastic encapsulation, and then put that into the ceiling panels of buildings, overnight when the cool temperatures or when the lower ambient temperatures come, nature can essentially freeze those PCM ice panels and store that colder temperature, those colder temperatures in that thermal battery in the ceiling. And then on the right side of the screen at the minute that you see in front of you, during the day, when the heat starts to be produced and the ambient temperatures start to rise, those charged PCM panels in the ceiling essentially act like a thermal sponge, absorbing all of the heat from within the room, and essentially meaning that you don't have the heat coming back into the room or the space. So essentially, those PCM panels act like a thermal sponge, keeping the room cool. And that is the very, very simple concept of how passive cooling and how PCM works. It acts in a very similar manner to how when you put an ice cube tray in the freezer and take it out and then put those ice cubes in a glass of water or in a drink, it keeps that drink cold for a set period of time until the ice melts. It's the exact same principle here, except instead of putting ice cubes into a glass of water, we are instead putting ice cubes into a building in order to allow the building to stay cooler. As part of that, obviously I mentioned we have a plastic encapsulation, which I actually have one in front of me here to quickly show you what it looks like. We call this ThinICE, but essentially is a plastic HDPE container. And what we do is we fill this with a solution, a PCM chemical solution. And for the purposes of this project and for this temperature that we're aiming for, which is 27 degrees Celsius, we select a product called hydrated salt. And so a hydrated salt PCM is essentially It starts off as an anhydrous, or it's basically a salt that has no water mixed into it. And we obviously add water to hydrate the salt. And then we use a mixture of salt and other chemical solutions together in order to create a final product that we can then pour into these plastic encapsulations that we can then put into the ceiling and freeze and melt at around 27 degrees Celsius, which gives us the correct temperature in order to allow for passive cooling of the room to take place. This is the encapsulation method. It's the ThinICE container I just showed you. Essentially, this is it in graphical form, but this is what we put those hydrated salt solutions into, because otherwise, if we were just to put them into the ceiling, the occupants would get very wet. It needs to be encapsulated in some kind of container. So within the Surefit project, the idea was to take three identical. There are multiple sites across Europe. The one I'm going to focus on is the location in Spain, in the city of Valladolid, which is about an hour and a half west of Madrid, or northwest of Madrid. And essentially here we were able and fortunate enough to have access to three identical buildings. And so what we came up with the idea to do within the project is to install PCM panels and passive cooling into two of the apartments and leave one of the apartments without any PCM. So that would give us then a control room or control setting in order to compare and contrast with the rooms that have PCM in them. This shows an overall layout of those apartments and how you can see there that they are practically identical units, giving a very fair comparison in performance over time. This is a schematic showing the PCM solutions that we selected for the project. So we decided to go with a couple of different PCMs rather than just picking one, so that we could compare the performance for our own benefit between PCM solutions themselves. And so in one of the rooms, we decided on 27 degrees Celsius PCM, which we believe to be optimal. And then in the middle apartment or building, we decided to put the no PCM panels. And on the right side building, we decided to put 32 degrees Celsius ThinICE panels or PCM panels. And the reason we did that was so that we could get a good comparison and see how the performance of the room and how the ambient temperature within the room changes based on a 5 degrees Celsius difference in PCM storage temperature. And so this will be very, very interesting over the next few months. These have been installed in Valladolid, Spain. And so it will be very interesting to see over the next few months as we're getting into the hotter summer months, how these PCM panels perform in reality and not just in modeling and within our labs. It'll be very, very interesting to see. Just a quick slide here to really show you that now that we have thermal batteries, essentially, with these PCM materials, we can apply them to all sorts of industries, as you can imagine. So not only can we do passive cooling, we can also implement it into heating. So if we change the temperature of that solution inside of the ThinICE, we can also bury it into the floor and then run underfloor heating through those same panels and basically improve the performance of the heating system. And by doing this, we just want to really promote all these different ways that once we have thermal energy storage systems, how best can we apply those into a building setting in order to improve the overall efficiency of the building, which is the primary focus of the Surefit project. So now that I've given you the breakdown over PCM and how passive cooling works, now I'm just going to give you a very quick and brief summary of the other technologies that are involved within the Surefit project. And I hope that I can do them justice. So the first technology here is a very interesting one, and one that I believe is a fantastic idea. And essentially, you may be familiar with solar collectors, solar panels. We see them all across Europe now. Generally speaking, though, most of the solar panels that you see on rooftops today are what we call PV panels. And all that means is photovoltaic, which essentially means that those panels generate electricity. And that's all they do. The idea behind these solar hybrid PV thermal collectors is that not only do they provide electricity, as do conventional photovoltaic cells, these also have the ability to generate thermal energy, which is a big deal because with the sun, you obviously don't just get electrical output, you can also get a lot of heat from the sun as well. And so these panels have a huge benefit of being able to combine thermal and photovoltaic technology to give you both electricity and thermal energy so that you can run hot water systems. This maximizes the energy generation and efficiency by allowing one panel to do two things you are heavily optimizing how efficient your solar can be. It also allows for the reduction of overall building energy consumption. And so as part of the project, we have worked with a company called Solimpex, Solar Energy Corporation, who are based in Turkey and have extensive research and knowledge about solar panels. And they've been in the industry for over a decade, selling all across the world. They have representation across Europe. And they have manufacturing across the world as well. So it's been invaluable working with this company in order to really develop this technology and utilize this as part of the same buildings as we've installed the PCM passive cooling. So the example I just gave you in Bio-aerogel of the buildings, we've also installed all of these technologies that I'm about to break down for you, but including this one, and so that we can essentially retrofit them on and then compare the performance of before and after, and as well as compare how easy it was to implement each of these technologies. But these panels that were provided by Solimpex essentially provide 540 watts of electrical energy and 700 watts of thermal power, which when combined is very, very powerful and effective within the building envelope. And we hope over the next few months to really show how effective this technology really can be, and why I personally think this should be more of a standard across Europe versus just using conventional photovoltaic. Because in my opinion, if you can get both photovoltaic or electrical energy and thermal, we absolutely should. The next technology comes from the University of Nottingham, and is another really exciting technology that I have a lot of passion for, and that is PV vacuum glazing, which is really quite amazing. You have to see it in person to believe it in honesty. And so essentially what this technology is doing is combining PV technology, like we've just spoken about, but putting that in within a regular vacuum glazing panel. And so what this essentially means is we can make a window for a building, but put solar panels within that window, which it seems like a no-brainer, really. If you're already going to have windows on a building letting natural light in, why not try to capture some of that natural light or UV from the sun and generate electricity? It sounds like it's a great idea. When you explain it to anybody, they generally say, "Well, that's a great idea." And so, yeah, essentially, you can see an image here of a panel, which is capable of producing roughly 52 to 86 watts per meter squared of electrical power generation. And these can be implemented into any conventional double glazing or PV glazing window system. And so University of Nottingham have developed and been creating these panels now for several years. And so the hope through the Surefit project is that we can work and we can build relationships with commercial partners, primarily PV vacuum glazing manufacturers, with the hope of promoting this idea and this concept and sharing real world performance data like the sites and the buildings in Valladolid, Spain, and across Europe with some of the other locations that we are installing these technologies, so that we can present the case that we believe moving forward, these should be more of a standard. Because at the minute, the common building practice is not to consider these technologies. It's to stick with what's comfortable, what is known, and what is established. And part of the project really is, and this is what European funding allows, is it gives us the flexibility to go out there and see if there is a better way of doing things. Because more often than not, if it's simply private enterprise spending money on R&D and investing in new ideas, they generally tend to play it as safe as possible, because obviously no business wants to squander or waste money. But with the freedom and flexibility that you get from EU funding money, it allows you to try those kind of risky ideas, those risky concepts that main businesses or big manufacturers wouldn't necessarily be willing to take those risks. So PV vacuum glazing is one of the great technologies that shows that benefit of EU funding, whereby we can go and really install these technologies and see how they perform in the real world and not just in laboratory or testing facilities. So I'm very excited to see. How this technology actually performs in the real world, especially over the next few months now that we're getting into the summer months with more sun. The next technology is a very fascinating technology. It's very interesting how this works. To me, it's not an area of my expertise, but I find it to be fascinating and honestly almost like magic. So these retro solar blinds are from a company called Costa. I hope I didn't butcher the pronunciation, but they are from Germany. And essentially what these blinds do, and I'm hoping you can see it clearly on the image on the right, they are very specially designed blinds with these unique grooves in them. And these are called special mirror optics. And they're actually on the louver surface or the blind surface itself. And what they're able to do is reflect heat. They take the heat away from the building by reflecting it away from the building and away from the window, but allow more of the actual light to pass through the blind. And obviously, what this is able to do is enhance personal comfort. And most importantly, the same, very similar to how the passive cooling and PCM solution works, it's aiming to reduce mechanical cooling. So that's a really key focus. If we can reduce the amount of mechanical cooling, which is generally air conditioning, that we need, we can improve the overall building envelope performance efficiency and also its energy wastage. And so this technology is pretty incredible. Based on the data that they've already released, it looks like it's capable of reducing the temperature within the room roughly around anywhere from 1 to 2 degrees Celsius, simply by installing this very clever blind design. So like I said, it's a technology or a concept I'm not an expert in, nor too familiar with how exactly the actual details of this work, but actually seeing it in person and seeing some of the figures that have already been shared about this technology and this idea, it definitely seems like this is a fascinating concept and one that I'm hoping through the Surefit project and working with more commercial partners leading out the end of this, we can really push this idea that just by making a very simple change in building material, blind material that we already put in houses, we can see a significant impact here, significant benefit. Anything that allows for the reduction of mechanical cooling is a good thing. And if it could be as simple as installing a new type of blind, then that's a fantastic idea. And so this, I'm very excited to see. Um, one, the performance over the next few months in Spain and across Europe, but also at the end of the project to see how the current manufacturers of blinds react to seeing the data and seeing this concept. The next technology is a big one, and it's basically called Silica aerogel panels, which essentially are a very, very lightweight, high insulation material. And they're very effective at reducing heat loss, as well as keeping heat outside of the building envelope. They are environmentally friendly and sustainable, and they are prefabricated and allow for modular installation, which is a key point of the Surefit project and what we're aiming for here. Are technologies that are easy to install. It's no good making something that is very expensive and very complicated to install. So the idea of these panels is that they can be prefabricated and cut into standard sizes off site and off location in a factory, and that they can then be shipped to site and essentially installed almost like Lego blocks. The easier, the better. But with a very simple and quick installation, you can significantly improve the thermal performance of the building. And if you can think back to my earlier slide at the beginning of this presentation, I showed a thermal imaging shot of of a house with insulation and without, and you can see how much heat is lost in the building envelope through poor insulation. So technologies like silica aerogel panels, which offer a very cost-effective, lightweight, and easy installation technique or product and technology, they represent a significant benefit for the market and for consumers or building owners in order to, but when they look at how they can improve their own building performance, this is one of the technologies that they can look at as a very simple, quick, and easy technology to implement. And so now I just wanted to very quickly, we actually recently had a visit to Bio-aerogel in Spain a few weeks ago, where we went to go and we were lucky enough to actually meet with the building owner of the 3 buildings that I showed you earlier. And here on those 3 buildings, they've installed all of the technologies that I've just spoken about. And so this is where we will be one of the key sites. We have a couple of others across Europe as well, but this will be one of the key sites where we are able to gather information and data so that we can see how these different technologies perform in the real world. Because it's one thing to do all of the laboratory testing and R&D testing and model how we think technologies will perform. But until you actually install them and put them into the real world and actually run them, you'll never see the true performance of how these systems are. So this is just a very quick video that was put together by our partners to show the recent trip that we went on to Spain and to just showcase how these technologies have been installed into the building. So if you don't mind, I will just play this for you guys. Perfect. And actually, I've noticed for my own benefit and for your benefit, there is one technology actually that I didn't include in my slide specifically, and it's this unit right here. This is a heat recovery unit, also developed alongside the PV vacuum glazing panels by the University of Nottingham. And so essentially what this unit does is a very low energy usage device that can essentially bring fresh air in to the space or the room and take out and extract heat within the space. And it can do this in a very efficient manner. And in fact, in the example and in the house in Spain, what the team there have been able to do is utilize the power from the PV vacuum glazing window to feed this into this heat recovery unit. So essentially, the power and the solar energy that you're able to get from the sun for free through the photovoltaics in the vacuum glazing panels allows for this unit to run essentially off grid, which means there's no need for any additional electrical input or mechanical cooling. So essentially, it can allow the building to run even more efficiently utilizing free energy, which anything that we can get our hands on for free is always a good thing. And at PCM Products here in the UK, we are very passionate about the idea that anything that we are given for free in nature, whether it be sun or wind for energy production, or whether it be simply nighttime cooler energy temperatures, if we can utilize those within the building envelope, any application for that matter, but especially within the context of this project, if we can use it within the building envelope to simply make the buildings we already have more efficient and utilize what nature gives us for free, that is always the best design philosophy and something we're very passionate about in order to push forward greener ideas and hopefully help take the planet away from the verge of going too far into climate change and having irreversible changes to our planet. So we're very passionate, all of the project partners are very passionate about this project and these technologies. And I can attest from the recent meeting I went to in Spain, it's it's a big passion of all the partners to really be able to push these technologies to market and have the end users benefit from better ways of doing things. We can't be stagnated in how we've always done things. We need to very much think about how we should be doing things and how we can do things better in the future because we all share one planet, and it is our duty to take care of that planet. So technologies like these are what we believe will allow us to hopefully play a small part in making that shift possible. And essentially, I'm a little going to watch that a second time, I don't think. I'm a little short on time, I think, of how far we were meant to go, but that just opens us up, hopefully, to a bit more time for questions and answers. I will stop sharing, I think. And what I will do, now, there was no sound on the video. Apologies. I do not know what caused that. I apologize. But for the Q&A, I think the way that it works is, I think in the top of your screen, you should see a multitude of buttons. At least I do on my screen. I'm hoping they replicate onto yours. You should have chat, Q&A, people, maybe only I see that. You can raise your hand and you can also react to the presentation, which hopefully I'll give it a thumbs up, see if it works. If anybody has any questions, if anybody would like to ask anything, I'd be more than happy to try my best to answer it. Oh, thank you, Ahmed. I see your question there. Perfect. Thanks for the presentation. Do any of these measures translate into savings per year on a typical house? It's a very, very good question, and it's very, very on point. And I 100% agree. That is the purpose of these this project and these demo houses, to do exactly that. So we know what those buildings were using before we installed these new technologies. And in the Valladolid, Spain example, we have 3 identical houses. And so, especially with the PCM at least, we can compare directly what a building with and without PCM, how it performs thermally. But all of those buildings, the building owner has the data for how much electricity and what the ambient conditions were in the properties, and how much energy has been used and how much it costs to run those buildings before we installed these technologies. And now he will know this upcoming season how much energy he is using now. And so we can make a direct comparison in real world cost as to what the real world tangible benefits are of the technologies. So thank you for your question. It's a very valid question. And it is one of the primary focuses and goals for these demo houses to get those types of figures so that we can promote them, mainly to the manufacturers as well as to the end users. But for these technologies to be mass produced, we need to have that data to share. It can't just be theorized or we believe these numbers. It needs to be, these are tangible real world figures. These results will indeed be published. Thank you again for the follow-up question. They will be published at the end of the project once we have all of the data. I also have a brochure that we have printed recently for the Surefit project. I will drop this in the chat box so that you guys can download that and have a peruse and read at your own leisure if you wish. But thank you very much for your question. I appreciate it. I'll drop that in there now. Sophia, hello. Thank you for your question. How PCM can work when we are experiencing temperatures of 40 degrees in the morning and about 28 to 29 during the night? Can they efficiently work in these temperatures? It's a very good question. Unfortunately, with the figures you've given, realistically, most likely there would not be a significant benefit just because the nighttime temperatures, unfortunately, don't swing further enough to get a benefit at nighttime. Unfortunately, this is why I think the project is so powerful, is we're trying to utilize multiple technologies because there's never one technology to fix all of the world's problems. It will take multiple solutions and multiple technologies to fix those issues. And the unfortunate thing with PCM, it will be interesting to see what data we get from Bio-aerogel. As I think if you can remember, we've installed two PCM temperatures, 27 and 32. So in the temperature ambience examples you've just given, the 32 degrees Celsius PCM would work. It would be able to go cool enough at night to hopefully charge those PCM panels. It will be interesting in Bio-aerogel to see what thermal performance we get, because there's no doubt we already know the 27 degrees Celsius PCM should perform better. But that's not to say there isn't a benefit at all to 32 degrees Celsius PCM. So in areas where we don't quite get those, nighttime ambient swings that we ideally would, want, nature doesn't always give us what we want and is not always predictable. But hopefully through the project, we should see some benefit. And if that's the case, that will mean that even in the ambient conditions you've just given in your area of the world, there may well still be a benefit, especially when you talk about 40-degree daytime ambient temperatures. And that's not including solar gains, direct solar heat impact on the building. So it will be very interesting to see. And I think that's why it's a good thing that we've selected two different temperatures so that we can get that performance difference. But thank you very much for your question. Hello, Sharon. Thank you very much for your question. How the PCM panel over the roof releases heat energy to the ambient? Is there a gap or contact between the ambient, between the PCM container and ambient? So essentially, these panels, which I have one right here, essentially all these panels do is they sit within the ceiling envelope. We obviously strap or mount them to the ceiling, and all they do there is they melt and they freeze, melt and they freeze. And in the process of freezing overnight, they are absorbing all of the cool nighttime energy or cool ambient energy. They're absorbing them kind of like a sponge, if you can, it's kind of sucking up all of the cool energy, just like when you put water in a freezer, it solidifies and freezes. These act in a similar manner, but not at 0 degrees Celsius in your freezer. They do this at 27 degrees Celsius or 32 degrees Celsius ambient temperature. And so overnight, these panels are freezing. And in the daytime, when the temperatures in the room rise, either through solar gains, people being and occupying the space, or turning on electrical equipment, these all generate heat. And as that heat naturally stratifies, we call, or rises within a room, that heat hits these PCM panels in the roof. And what happens is these essentially start melting. It starts melting this PCM, just like your ice cube in a bottle of water or a glass of water. So what that does is effectively acts like a thermal sponge. So the heat goes up and is being absorbed by these panels in the process of melting them. And that means that if the heat goes up, it actually never comes back down. And so you get natural passive cooling within the building, within the room, without the need for any mechanical cooling. Air circulation, either through wind or through a simple fan, low energy fan, is enough to keep the comfort within the space. because the actual temperature is not increasing, if that makes sense. And thankfully, in most climates, the mornings and the late kind of evening are cooler than the kind of middle of the day, middle to kind of end of the afternoon. That tends to be the peak heating kind of period, and that's when these become most effective. But thank you very much for your question. I hope that answered it. But if you have any follow-up, just please feel free to type. Are there any plans to split up the data? Who was this? Sorry. Manuel, hello. Thank you for your question. It's my pleasure. Are there any plans to split up the data and perform analysis on each specific measure's savings, or other studies more focused on their aggregate and combination? It's a very, very good question. In fact, it's both. So essentially, we are monitoring, or we have a lot of monitoring devices within these buildings. We are monitoring the performance of each technology individually so that we can assess individual performance and how it stands on its own 2 feet. But we are also combining those technologies to see how they perform in conjunction with each other. And I think that's very important to do because, like I said, there's not one specific technology that can solve all of the world's problems. It will take a host of different ideas, concepts, and technologies to achieve that. And the purpose of this, by utilizing so many interesting and innovative ideas, is to find what really works. It will not take us very long to figure out whether this is a good idea or not a good idea when it comes to these technologies. The numbers will be very transparent and very, very easy to hopefully understand and sell, most importantly, if the ideas are what we believe to be good ones. It should be a lot easier to sell once we have all of that data. But thank you very much for your question. Ahmed, thank you for the follow-up question. With regards to the blinds, are there any prospects for improved performance? I cannot see the cost justified for 1 degree drop in temperature in the room. It's a very valid question, Ahmed. Very valid indeed. And I know 1 degree doesn't sound like an awful lot. 1 or 2 degree, when you hear the figure, it doesn't equate to a lot or a significant number. But when it comes to mechanical cooling and air conditioning, 1 degree Celsius can actually make a fairly substantial difference. But, and in relation to your question, you're absolutely right. At what cost? If it was free, then we would say 100%, 1%, 1 degree Celsius drop in temperature is a huge deal. But you're absolutely right. None of this equipment that I've just spoken about is free. All of it costs money. And so it's no good installing a technology for 1 degree Celsius cooling that costs an obscene amount of money. Absolutely right. So it is a huge part of the project that by the end of the project, we will have figures for how much it will cost to actually make and sell these. Because the one thing we have to always keep in mind at this stage, a lot of these ideas, a lot of these technologies are prototypes, are experimental. So pricing is based on very low volume of manufacturing. We're talking about 1 unit here, 10 units there. Once you get to mass manufacturing, those unit prices can come down significantly once you've spent money on setting up molding and standardized procedures and processes. Those costs can come down. And so part of the project's goals is that once we prove the technologies actually work and do what they say they will, then we can look at how much we could realistically manufacture these things when it gets to the mass manufacturing stage, because then that will give you a much better idea over, like what you just said, is it worth the money or is it not worth the money to get 1 degree Celsius or 2 degrees Celsius cooling? I hope that answered your question, but it's a very valid question and one that we are very much in our minds, that we understand. Look, it's not just good. It's not good enough to just have a good idea. That idea also needs to be sellable and affordable, and to have a real tangible economic benefit to the users. Sharon, thank you for the follow-up question. What is the lifetime or number of cycle operation of these panels? Can you please tell? What about the thermal conductivity of the plastic container? That's a very valid question. The thermal conductivity of the plastic panel, I don't actually know off the top of my head, but we do have that on our spec sheet, so I can certainly provide that. What about you said, what is the lifetime or number of cycle operation? That is a very good question, and one we get often. The life cycle of the PCM is for 30 plus years. Because these solutions are basically almost vacuum sealed within these containers, and we use a triple sealing method to make sure no oxygen can get into the panels themselves or within the solution inside the containers. Thermal reactions don't degrade in the same way you may be familiar with electrical. So lithium ion batteries, for example, the way that the reaction within those panels or cells work, over time, as you charge and discharge, eventually that lithium-ion battery loses its overall percentage of energy that it can hold. That same phenomenon is not present within thermal chemical reactions. It doesn't translate exactly the same as electrical. So we do life cycle testings on these solutions. We run them thousands and thousands of times within our machines in our labs, and we don't see a drop off in thermal performance even after thousands of cycles. So our belief is these things should live as long as the building lives. Most modern buildings are, rated for about 50 plus years, and so we believe these panels should live alongside the buildings, and not need replacing, and should not degrade over time. Joaquin, thank you very much for your question. Sorry, it's not a question, it's a response. hmm Yeah, it's a very valid point that Joaquin mentions. Um, there's the visual comfort as well. Yeah, absolutely. So I think the big thing with those blinds, and the reason it's such a, for lack of a better word, a cool concept. Pardon the pun, with the actual cooler ambient temperature it creates, but it does also allow a lot more light into the space. So you can see behind me, I have some conventional blinds. And if I want to allow more light into the room, which I thought about doing when I was hosting this webinar, I wanted to be well lit, so I looked better for you all. I had to fully open the blind to get a decent amount of light in. Unfortunately, that then actually made me not stand out at all. It just washed me out on the screen. But with these blinds that we're talking about, these examples, this new technology, I could hypothetically have the blinds further open, allow a little bit more light in, but not at the expense of increasing the temperature of the room. So the visual kind of personal comfort level within the room is improved. And to some people, they may actually concern themselves predominantly with the amount of light in a room rather than just the ambient temperature itself. So there's a couple of different motivations for why somebody may consider that technology. They may not consider it purely from the um, thermal performance of the envelope or the space. And they may be looking at it purely from I want to have a bit more light in the room to make it a bit more lively and a bit more word pleasant to be present in that room. Does anybody have any more questions? Or whilst I have a minute, I will drop. How do I apply? Um, Let me see if I can figure out how to put this brochure. Can I do it this way? Maybe. I did give me the option of this. So I'm just very quickly trying to see if I can actually do what I said, which was to put this. Does not allow me. That's a very good question, Ahmed. Thank you very much for that. We have a website specifically for the Surefit project, and I will actually give you all the link now in the chat box. And so that is actually the direct link to our Surefit project website. And so from there, we will be updating all of the data, and all of the progress that we make over the next year. And over the next 6 months, especially, there's going to be a lot of interesting data coming. We are now coming into summer, although here in the UK, you wouldn't believe that it's summer based on the weather, but our European friends are much more lucky than we are here in the UK when it comes to weather. So we will be getting a lot of interesting data over the next 6 months. There is also a LinkedIn profile too, which I may actually be able to link that as well. Actually, it may be on the website. Let's see. Yes, it is. So yeah, LinkedIn and the website, the actual project website, are two of the really direct resources to get updates with regards to the Surefit project and to see how all of our work is going. Ahmed, you absolutely can. So on the website for Surefit, there is a partners tab that gives you all of the website links to all of the companies and the technologies that I've just showcased. And so you can absolutely go to each of those company websites and fill in the contact sections and reach out to people from each organization and each company. Absolutely. We would be more than happy to talk with anybody, whether it be potential end users or any stakeholder, essentially manufacturers, installers, sellers, wholesalers. Everybody and anybody is welcome, and we need everybody and anybody. I hope I did a good enough job of explaining the fact that it isn't just good enough to come up with an idea. You need to also work with the people who are going to potentially manufacture these things, the people who are going to promote and sell these things, the people who are actually going to use these things, but then also who is going to install these things. It's no good if you have all the other bits, being able to make it, being able to sell it, and being able to use it if you have nobody who can install it. So there are multiple stakeholders that need to be worked with, integrated into this. And it's one of the things we've been learning already during the installation phase of these technologies. Who on earth can actually install these ideas? Because a lot of them are revolutionary. They're brand new. They've never been done before. So when you mention it to somebody, they don't even know where to begin because they've never done it before. So that is something that will take time. That hence things like this webinar and going to trade shows, which we are also actively doing, allows for us to engage with a really large group of stakeholders and allow us to get input from experts in all fields, because you can never be an expert in all things. You focus on the things you are expert within, but then you work with people who are experts in other fields in order to get their invaluable feedback. So I super very valuable feedback. Uh, we would handle that here in PCM. We're ourselves and University of Nottingham are the two predominant UK partners, with obviously University of Nottingham being primarily an academic research institute. Here at PCM Products, we are predominantly a private sector manufacturer, and so you absolutely could reach out to us if you so desire. If you have any questions or would like any more information on the technologies themselves. No, my pleasure. Thank you for all your questions, Ahmed. I very much appreciate it. Thank you so much. You too, Sharon. Thank you so much for being so friendly um, and welcoming. I appreciate it. I hope I didn't ramble for too long. I appreciate all of the positive feedback. But yes, I mean, I think that brings us pretty much to the end of the webinar. If there are any other further questions, please do just drop them in the chat box very quickly. But if not, then I feel like a teacher in school. You are all more than welcome to leave. I very much appreciate all of your time and for all of your questions. Thank you very much. My pleasure. Thank you, Sophia. Thank you, Joaquin. Thank you, Louisa, and Themis, and Tiago and BJC, before I forget people. Thank you very much, all of you. I really appreciate all of your support. I hope you all have a great day.